Hey all, today I'm going to record a video on circles. I think this is kind of in the packet. It was kind of towards like page maybe like 4. I don't think it was actually the next section, but it's easier to do circles before you do ellipses. So I'm going to go ahead and do circles today. Again, I'll list the specific pages in the pack to accompany this. So when it comes to the circle, the definition is the set of all points equidistant from a set point called the center. The equation of a circle is x minus h, and just kind of like with the parabola formula, um, the h and the k are the center. For the parabola, it was the vertex, but in the circle, it's the center, and the radius is the r in the formula. And note that over here in the equation, it's r squared, not just r. But when it comes to a circle, if you think about what the definition is, it's the set of all points equidistant from a set point called the center. So if this is my center, say it's C, what the circle is the collection of all points that are, let's say the radius is 6. It's a set of all points that are 6 units away. So it goes like all the way around like that. And that's how, in the end, you get the circle. So if we were talking about something in the coordinate plane, let's say like this is my center. And let's say the radius is 3. So I would go like 3 this way, 3 up, 3 left, 3 down. And that would kind of be what my circle would look like. All right. Excuse me. So the first example that I have here, it's an equation of a circle that's written in standard form. This is what we would call standard form of a circle. And you basically, I'm just asking you guys here to just tell me what's the center and what's the radius. So if we look at this equation, because there's nothing in the parentheses with the x, the h in that case would be 0, because it's like there would be no purpose of putting x plus 0 squared. So in this case, it's just going to be 0 for the coordinate. So our center is going to be 0 for the x, or for the h, and then we need k. And note that in the formula, it's minus for both of these. So just like when we were dealing with the parabola with the vertex form, it's always the opposite when it comes out. So since it's a plus 2 here, it's going to be a negative 2. So that's my center. And then my radius, again, note that in the formula, it's r squared. So since it's r squared, it's going to be the square root of 121, and the square root of 121 is 11. Next example. For the next example, again, it's in standard form. I'm asking you to figure out, again, the center and the radius. So for this one, again, hk is the center. So this is our h, this is our k. This is a negative 3, so again, it comes out as the opposite, so this will be a positive 3. And this comes out as the opposite, so it'll be a positive 4. And then the radius is, the radius squared is 25, so the square root of 25 is 5. And the next example, again, try it on your own for a second, but in theory, center is the opposite here, so it should be a positive 5. Opposite of this, so negative 4. And then it's going to be the square root of 41. Now, you can leave it as the square root of 41, or you can go ahead and get the decimal. Normally, we'll just leave it in radical form, so I would just leave it like that. But just in case anyone did get the decimal, it's approximately 6.2. All right, next slide. All right, so on the next slide here, it says to write an equation of the circle given the center and given the radius. So once again, here's the equation of a circle. And since we have the equation, we simply need to just plug in the center and the radius. Well, the radius squared. So again, it's hk, that's the center. So if the center is given to us here, that means that the first thing is h and then that's k. So it'll be x minus 2 squared plus y. Again, it's minus in the formula, and then it's already a negative 4. So minus and minus becomes a plus 4 squared, and then it's equal to the radius squared. So 4 squared is 16. So that should be our answer for the first one. For the second one, go ahead and do that one. For that one, it'll be x plus 7 squared plus, and it's always plus in the middle, and it's going to be y minus 1 squared equals, and 15 squared is 225. Next example, we have 3 and 0 as the center, so it'll be x minus 3 squared plus y minus 0 squared. Again, that wouldn't be standard form because it's a 0, so I'm just going to erase it. Habit was just to put the minus there, but since it's a 0, we're just going to leave it as y squared. If you put y minus 0 squared, it's not wrong, but again, just get used to how you would actually see it on a test or something like that. It'll be just the y itself. Equals, and now this is 1/3 squared, so we did this a couple of times when it comes to fractions. If we're squaring a fraction, we square both the top and the bottom. It's like you distribute it. So that's going to be 1/9 for my radius squared. All right, and then the last one is number 4. So for number 4 here, it's going to be x plus 5 squared plus y plus 3 squared equals. Now I'm going to do this over here because we've done this a few times when we're squaring this. Again, just like the fraction we just mentioned, you have to like distribute the exponent. So the 3 is squared, that gives me 9. And root 2 squared is 2. A square root squared, just they cancel out essentially. So we end up with 9 times 2, which is 18. Next slide. All right, for this slide, it says write an equation of the circle given the graph. So for the first one, the graph is here. Well, all the graphs are coming in. For this first one here, the graph is here, and you have to figure out, in order to write the equation, you need the 2 important things, the center, which is your HK, and you also need the radius. So those are basically the 2 things you want to figure out from the graph, and then just plug them in. So from the graph here, my center is this middle point. This graph, no, because I did this one by hand, it's not the best of circles, but the center is indicated right there, so it's a little clearer to know what the coordinates are. This is 0, 0, so it's, that's 0, 0, so it's 2 to the left and then 3 up. That's my center. So my center is -2, 3. My radius, I could just count how far it is over. So it's 1, 2, 3, 4. You could double check by counting like vertically as well. That's also 4. So my radius is 4. So my equation would be x plus 2 squared equals 16. All right, let me see what the last one looks like that I had here. I'm trying to see which one we should do. Well, it doesn't matter. I'll just do one of them. We don't need to do both. But I guess for this one, I'll pick number 3. For number 3, to figure out the center, it would be here. So for that, my center, the coordinates would be 0. If you look, even though there's like 6 boxes, if you look at the scale here, it's 6. I'm sorry, it's 3. So it's going by 2s for every box. So just keep that in mind. So the center is going to be 0, 3. So again, that's why I'm doing this one, because I want to make sure you guys look at the scale. So that is 0, 3. And that means the radius, if you're counting, again, it's 1, 2, 3, 4, 5, 6, but it's really 3 because 2 boxes is 1. So the radius is 3. And therefore my equation would be x squared plus y minus 3 squared equals 9. And again, because it's a 0, we don't put anything there. Next slide. All right, so the next slide is where it can kind of get a little tricky. It says write an equation of a circle given the coordinates of the diameter. So this is going to mean a few things. You have to first think about a circle. So let's just let me give you a quick sketch. Here's my circle. Hopefully everyone knows that this is the radius, and the diameter would go all the way across. So it's a segment with both endpoints on the circle. So it's got to specifically have both endpoints on the circle, and it has to pass through the center. So the diameter is a combination of 2 radii, this one and this one. I know the stylus, I'm still messy, but it is better with my stylus. Anyway, so keep that in mind here. So the diameter is 2 radii and the radius is half the diameter. That's how their relationship works. Everyone, again, should already know that. This is going to bring up is some work with the distance formula. I believe the first video I posted for you guys was kind of the first section of this chapter, 10.1, is talking about distance and midpoint formula. The reason for that is a lot of times we're finding the center and things like that, and the formulas will be relevant. Anyway, the reason this is going to help is because if you know the connection between the circle being like, so this is, let's say, for this particular example, this isn't going to fit on the graph, but let's say it did. 7, -3. All right, so here's 7, -3. Obviously, that's 5, -3, but you get it. And then it's -2, 6, whatever. Just putting a random point up here. I'm not trying to be relevant. So this is my diameter. It's going to go all the way across. What you need to understand is that the radius, I'm sorry, not the radius, the center is going to be dead center from that. So it would be like the middle of the diameter. Finding the middle of the diameter is the midpoint. So that's what the purpose of like this formula is. You find the midpoint of a diameter, you know the center. Then the other formula, the distance formula, is if we find the length of the diameter, let's say it was 12, I'm just making up numbers. If we know what the diameter is, then we should be able to find the radius because it's half the diameter. So it would be 6 and 6 or whatever the case may be. So these two formulas are going to be useful because, one, by using the distance formula, we can figure out the length of the diameter. Therefore, if we know the length of the diameter, the radius is half of that. And it's also useful because, again, the midpoint is going to be the center of the circle. So that's the purpose of this slide, is to help to get comfortable with using the formulas. So for this only example that we have here on this slide, the diameter has endpoints. A diameter has endpoints 7, -3, and -2, 6. So when it comes to these, you're going to label it x1, y1, simply because it's first, and that's the x coordinate, and that's the y coordinate. The second point will be my x2, y2. Again, simply because it's second, and that's my x and my y coordinate. And then we find the center. Again, as I explained for this little sketch up here, which is horribly messy at this point, the center is the midpoint of the diameter. So I'm going to use this midpoint formula. So it's going to be, if I'm using exactly what I have here, it's going to be 7 plus a -2 over 2. And then I have -3, 6, I'm sorry, plus 6 over 2. And then I do the calculation, I end up with 5 over 2 for this, and I end up with 3 over 2. So my midpoint, or my center, is going to be 2.5, 1.5. That would be the coordinates of the center. Now, the next that we would want to find is the length of it. Finding the length requires us using the distance formula. So I'm going to, again, plug in. Distance equals, I don't know if I left myself enough space to write the d, so I'm just going to not write that. It's going to be the square root of x1 minus x2. So it's going to be 7 minus a -2 squared plus -3 minus 6 squared. I'm going to skip a couple steps just because lack of space here, but square root. So minus a minus becomes a plus. So we end up with 7 plus 2. So that's going to be 9 squared. Plus. Second group, we get -3 minus 6. That's going to be -9 squared. 81 plus 81. It's going to be the square root of 82. I'm sorry, 162, where that came from. And the square root of 162 is going to be 12 point something. I have no idea. Oops, sorry, put squared in my calculator. Square root of 162 is 12.7. So you could leave it like this or get the decimal. Again, that's 12.7. And if my diameter is 12.7, then that means my radius would be half of that. So we can just take half of that 12.7, and 12.7 divided by 2 is 6.35. So just being comfortable with these formulas will be relevant on the next slide or so. All right, so now we just reviewed the formulas on the previous page for distance, for midpoint. And our first example on this slide is going to be using the coordinates of the endpoints of the diameter. It says, given a circle with these as the endpoints of the diameter, we need to write the equation. So again, the equation, here it is x equals yada yada. So the things we need are, we need h, we need k, and we need the radius. So we need to figure that out from this, just given the 2 points. So we'll start with figuring out the, I guess I'll go with the length of the diameter first. So it's going to be the square root. Excuse me. Again, I guess I should have labeled it. This is x1, y1. This is x2, y2. And again, I'm going to start with the distance. I can do a little better than that. So since I'm starting with distance, I'm going to plug it straight into the formula. It's right up top there. So it's going to be the square root. It's going to be 5 minus 3 squared plus 1 minus a negative 1 squared. Again, note that the negative here is not replaced by that negative. It becomes a double negative. Square root. This is 2 squared. This is negative 2 squared. Negative 2 squared and 2 squared are both 4. So it's going to be the square root of 4 plus 4, which is the square root of 8. And I could simplify that radical. This is 4. So that would be 2. That is the diameter. So since the diameter is 2 root 2, that means the radius, I'll write it over here, is half of that. So 2 root 2 divided by 2. So the radius is just root 2. Now we need to also find the center. So to find the center, we need the color. Here's the formula. Again, it's midpoint, but the midpoint. I have my x1, y1, x2, y2. 5 plus 3 over 2. And then it's going to be 1 plus negative 1 over 2. It's going to be 8 over 2. It's going to be 0 over 2. 8 divided by 2 is going to be 4. And 0 divided by 2 is 0. So that's my center. That's my radius. So now I can write the equation. The equation, again, h, k. So it's going to be x minus 4 squared plus, it's going to have the y squared because we don't need a 0. And then the radius is the square root of 2, so it's the square root of 2 squared. So this is just going to be 2. Perfect. All right. Telling myself perfect. All right, so here's the next one. So for the next one, I'm giving you the same situation, the diameter endpoints. Hopefully you guys take a second to actually try it. And that's the answer. If you pause for a second, whatever. That's going to end up being the answers. This is our radius. This is our center. So we get to that final equation and we plug it in. So it's going to be, for this one, x minus 3 squared plus y plus 1 squared equals the square root of 5 squared is 5. Next slide. All right. Now this is really going to test my stylus skills or lack thereof on this slide. It's graphing the circle in the coordinate plane. So the first thing you want to do is just figure out what the center is. The center from this equation, hopefully everyone is comfortable with this, it's going to be negative 1, 2. Again, it's hk, and the radius is going to be 3. Because again, remember this is r squared, so we'll take the square root of that. So now we know the center, we know the radius. So let's start with the graphing it. to graph, we're going to plot the center. It's going to be -1, 2, -1, 2. So that's our center. And then our radius is 3. So basically, you're just going to count out, go left, right, up, down, and make a circle from there. Obviously, it's not going to be perfect, but it will be like 1, 2, 3. Sorry, I didn't mean to do that in yellow. It'll be a little better than that. It'll be 3 out. So 1, 2, 3, put a point. 1, 2, 3, put a point. 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 And then, just try to make it look as circular as possible. Probably best if you like etch it a little bit like that. Whatever. But something like that is how it should look. Next example. All right, here's my equation. Again, I need to know the center, I need to know the radius, and then I can graph it. So from this one, my center would be -2, -3. Again, they come out as opposites. And my radius for this one is 2. So let me graph it. Start with the center. -2, -3. Radius is 2, so I'm going to go 2 out in all directions. So 2 up, 2 left, 2 down, 2 right. And then pretty much just try to make it look circular from there. All right, that's how the graphs would go. All right, so writing an equation of a circle in standard form. This will probably be the trickiest thing in dealing with the circles. As you can see here, I just pulled up a table with some different steps on it. This will kind of give you some type of guidance as to the process you need to follow. The first thing here says to group blank and leave a space. I'm not really too big on leaving the space, it's up to you, but we want to group the x's together. The second thing we want to do is group the y's together. And then we want to move the constant. I'll explain that in a second. So by that, basically that means we want to start off from each problem. We want the x's to be joined together. And we want the y's to be joined together. And then we can move the constant. So this constant we want to move over to the other side of the equation completely. So what that should look like is, let's start with getting the x's together. So for my x's together, I want x squared plus 16x together. Then it's a plus. Then I want my y's together. My y's are y squared minus 22y. And then again, the last thing I want to do is move that 20. So to move a minus 20, I add 20. So it would be 20 on this side of the equation now. That would be basically the first step, kind of doing all of that in one. That's like preparing the terms. Now what we're going to do is we're going to do 2 different completing of the squares. We're going to do it with the x's and we're going to do it again with the y's. So when we start with the x's, the completing of the square process, hopefully you remember this, is that you're going to take half of b. So in this case, b is 16. So half of 16 would be 8. So it'll be plus 8 squared. Then we do the same thing for the y's. It's going to be half of our b. So in this case, it's -22. So it'll be a -11 squared equals 20. Now, you're going to add whatever your b over 2 squared is to the other side. It says both sides. You're already adding it to this side by just completing the square here. It's already bringing in that extra term. So I don't really need to do it here. So now what we're going to do is add that b over 2 to the other side. So this case, it was 8. So 8 squared is 64. We're adding that here. This case, it was 11. So 11 squared is 121. We're adding that over here. Oops, 121. And we're going to end up with the following. It'll be x plus 8 squared plus y minus 11 squared equals, no idea what that is, 84 plus 121 is 205. And that would be the equation. And if I ask you further, what would be the center would be using these. So it'll be negative 8, 11. Sorry, that's an 11. And the radius would be the square root of this 205. Next slide. All right, so here's another one where we have to write the equation of the circle in standard form, which means it has to look like x minus h squared plus y minus k squared equals r squared. So let's do it. Get the x's alone, not alone, but together. So it'll be x minus 12x, x squared, minus 12x, the y's, plus 8y. And again, we want to move that 32, so we would subtract that 32. And this will be a negative 32. And now let's start by doing the completing of the squares. So it's going to be x minus half of this is 6 squared plus y plus, it's a plus, half of this is 4 squared equals negative 32. Again, at this point, the key piece to make it all work is we have to add the squares of these. So negative 6 squared is 36, and 4 squared is 16. So we end up with x minus 6 squared plus y plus 4 squared equals, it's going to be 420. That's my answer. Now the next two slides have a few more examples. I'm just going to go through them pretty quickly. This one's a little bit different because it doesn't have a constant, it doesn't have a linear term for the x's. So first thing I'll do is move the 4. So it'll be x squared plus equals the 5. And then we need to go ahead and do our squares. Again, since the x squared is by itself, hopefully everyone realizes that that means it's a 0 for that term for the coordinate of the circle. I'm sorry, for the coordinate of the center. And then this is going to be y plus 2 squared. The the 2 squared is going to be 4. So that gets added on here. So it'll be x squared plus y plus 2 squared equals 9. Answer. Last problem. Praise God. All right. Sorry, stretching my back. First thing I want to do here is, again, I want to get this to look how we need it. We need all the x's and y's on the same side. So in that case, hopefully everyone realizes this has to move. So we'll have x squared plus 2x plus 2y, plus y squared minus the 10y, because we're going to, again, move that over, equals 55. And then from there, let's get to grouping. The x's are already together. So, and then my y's, oops, I don't need that plus sign in places, but whatever. My y's are together, so it'll be x plus 1 squared plus y minus 5 squared equals 55. Hope you guys don't hear the TV downstairs. It's like 2 floors down. It's so loud. But anyway, now we go ahead. We have to add the this term to be over 2 squared. So 1 squared is 1, and negative 5 squared is 25. So it's going to end up being x plus 1 squared plus y minus 5 squared equals, that's going to be 86. 70, yeah, 86. That was wrong. And that would be our answer. All done.